All right, in this video we're going to do essentially the same thing we did in the last video. So I'm not going to redo the half reactions and all that kind of stuff, but we are going to label this diagram right here just to show you what this looks like in the porous cup. So if we jump back to here, I've left the half reaction that we've already completed, and up at the top I'm going to draw in this this other setup, but I'm going to expand it just so I've got a little bit more room to draw and play around with. Okay, so this is a little wider than the one in your diagram, but it's essentially the same thing that's going on. So I'm going to draw this in just so you can see that that is in there, although it doesn't show up in your diagram. So the same idea, the difference here is instead of two beakers separating the two solutions, we have this thing right here that we call a porous cup. And porous just means that it has pores. It can allow things to go through it. So let me show you what it actually looks like. This guy right here is a porous cup. So it's kind of made out of a ceramic kind of a material that almost feels chalky, although a little bit harder than that. Kind of like you made a clay statue or something and cooked it in a kiln. That's kind of the sort of a feel that it has. But this will allow ions to travel through it, and that's its purpose. But it still allows us in our thing to have two separate compartments. So for example here, I could still have my copper 2 positive ions as well as the nitrates. I can write an N. This one would still be my copper solid. In outside of the porous cup, just out in the beaker, would be zinc solid, and then the zinc 2 positive electrolyte in the solution. So the reaction stays exactly the same. Everything that we've got at the bottom, copper 2 is still wanting to gain those electrons from zinc, so my electrons are still going to flow from this side to that side. We're still going to have a buildup of copper solid over here as copper 2 ions gain those electrons, and we're going to have a buildup of zinc 2 positive on this side as this electrode breaks down and gets smaller and smaller and smaller. The major difference here is instead of the ions moving through the U tube like on the last one, they can pass directly through the porous cup. So, oh, I forgot to write my nitrates over here. So we've got these positive copper 2s, negative nitrates, positive zinc 2s, and negative nitrates on the two sides. And as this reaction takes place, the copper 2 positives are becoming solid, so this one is becoming more and more and more negative. This side is becoming more and more positive as we create more and more zinc 2 positive ions. So these need to move in order to try to balance that out. So I'll show you this in the next video too, but remember that the copper is my cathode and this is my anode. Remember, those are always the solid electrodes, so we're talking specifically about the zinc solid and the copper solid. And those electrodes are they help me understand what's going on, okay? So, for example, one of the things you're going to learn in the next lesson is that electrons always flow from the anode to the cathode. So if you can identify anode and cathode, you know where your electrons are going to flow. The second is that cations, positively charged ions, always move towards the cathode. So these positively charged zinc ions are going to move, actually let me make that red, they're going to move through the porous cup into the other solution to try to balance the charge. And negatively charged ions, or anions, are going to move through the porous cup towards the anode. So anions always move towards the anode, cations always move towards the cathode. And the purpose of that is to always try and balance that charge out. So that's the only difference. Everything else about this stays the same. The reaction stays the same. The only difference is that how the charge is balanced, whether it's through that U-tube or whether it's through moving through the porous cup. All right. Yeah, that sounds good for this video. On the next one, I'm going to show you how to figure out the voltage that this cell would produce.